This video is about deriving 3 further equations of motions and applying all 5 equations of motions to solve problems with constant acceleration. So from part 1, we already know these 2 equations. So equation 1, which is equal to v is equal to u plus at, and equation 2, which is s is equal to u plus v over 2 times t. Now we want to derive 3 further equations from this. So for the first equation, make t the subject in 1 and then substitute into 2. Then what you end up getting is, when you make t the subject, you get v minus u over a is equal to t, which implies s is equal to u plus v over 2 times t, which becomes v minus u over a. If you expand the top, you end up getting uv minus vu, so they cancel that. So all that you end up getting is v squared minus u squared on top, and the bottom you get 2a, and if you rearrange it, you get 2as is equal to v squared minus u squared by multiplying both sides by 2a. And then if you add u squares to both sides, then you end up getting v squared is equal to u squared plus 2as. So that is equation 3. Okay, for the next equation, just substitute 1 into 2. So what you end up getting is v is equal to u plus at. So everywhere you see v in the second equation, replace it with v plus uat. So s is equal to u stays the same. The v becomes u plus at all over 2 times t, which is the same thing as 2u plus at over 2 times t, which is equal to, if you expand the bracket and separate the two numerators out, you get 2u over 2 times t plus at over 2 times t. So if you simplify that, you get ut plus half at squared. So that is the fourth formula that you need to know. So we've got already 1, 2, 3, and 4. To derive the last one, make u the subject in 1 and then substitute into 2. So u is obviously going to become v minus at. So if you substitute now into 2, s is equal to, u becomes v minus at plus the v that remains there over 2 times t, which implies s is equal to 2v minus at over 2 times t. If you expand it and simplify, you get s is equal to 2v over 2 times t plus, sorry, minus, not plus, minus at over 2 times t. If we simplify, we get s is equal to, the 2's cancel out, so you get vt minus half at squared. So that's the last one. Now in the exam, they are given to you in the formula booklet. However, it's easier if you memorize this, because then you'll be much quicker going through these questions. So I would advise you to memorize all these equations. So this is equation 3, 4, and 5. Okay, so let's go through some questions. So in the first question, I've left them on the side, but in after the following questions, they won't be there. So you have to memorize these in order to follow these my examples. A particle moves in a horizontal line from A to C via point B. So we've got A, B, and C has a constant acceleration of 1 meters per second squared. So when we label acceleration, I normally label it with a double arrow, and it's 1. So 1 meters per second squared. And passes point B after 6 seconds. So from here to here is 6 seconds. And point C after a further 4 seconds. So 4 seconds here. Its velocity at C is 50 meters per second. So 50 meters per second here. And normally draw an arrow, single arrow to denote a speed. Draw a velocity time graph of the information you have using SUVAT using SUVAT equation. Calculate the distance AB and BC. So because acceleration is equal to 1 meters per second squared, that means, and this is the velocity time graph, which is measured in meters per second, and time, which is in second. We know at 10 seconds, the velocity is 50. Now, because the acceleration is 1 meters per second squared, velocity was increasing by 1 meters per second. So that means right at the beginning, it must have been 40, because in 10 seconds, it should have increased it by 10 meters per second. Okay, using SUVAT equation, calculate the distance AB and BC. So that means because there's two different speeds that it's most likely it won't be the same. There's two parts to the journey, A to B to B to C. We have to calculate each one separately. So journey from A to B, so A to B. Okay, so S is equal to U is equal to V is equal to A is equal to T is equal to. Now we're trying to find the distance, so that is what we're trying to find. So I'll put a question mark at it. Now, if it's A to B, we know that this is 40 and that is 46, because remember, acceleration is 1 meters per second, so 40 meters per second and 46 meters per second at B. So A to B, the initial speed is 40, the final speed is 46, acceleration is 1, time is 6 seconds. Now, because you have everything here, you have range, you can use any of these formulas, but I'm going to go for this one. So S is equal to U plus V over 2 times T. So S will be equal to 40 plus 46 over 2 times 6. If you put that into a calculator, you end up getting 258 meters. So from A to B, the particle has traveled 258 meters. So you need to do the same thing from B to C. So setting up SUVAT for the journey from B to C. The displacement or the distance is what we're looking for. Initial speed is 46. Final velocity is 50. Acceleration is still 1. The time is 4. Again, I'm going to use the same formula, which is the displacement formula. U plus V over 2 times T. So S is equal to 46 plus 50 over 2 times 4. We put that into a calculator, we end up getting 192 meters. Okay. Oh, so we had to work it out separately, actually. Calculate the distances A to B and B to C. So A to B is this one, and B to C is this one. A car is traveling with a uniform acceleration along a straight road. It passes through point A, so wherever acceleration is constant. Passes through point A with a velocity of 8 meters per second. And 5 seconds later, it passes through B with a velocity of 25 meters per second. So 5 seconds later. Find the velocity with which the car passes through the midpoint of A and B. So first thing we need to do is work out acceleration, because that will help us solve a lot of problems. So do we know the distance or displacement? Nope. We know the initial speed is 8. We know the final speed is 25. We're trying to work out acceleration, and time is 5 seconds. So we've got, if you look at it, got u, v, a, and t, which means we're using the formula involving those 4 unknowns. So v is equal to u plus at, which means 25 is equal to 8 plus a times 5. If I rearrange it, I get a is equal to 25 take away 8 divided by 5, which means a is equal to 3.4 meters per second squared. So 3.4 meters per second squared to find acceleration. So from A to B, this was the journey from A to B. Okay, now we need to find the displacement. So displacement is of the whole journey, so how much distance from A to B. So we can use the same SUVAT setup because it's still the journey from A to B. So S will be equal to, we have a range of answers again, range of formula we can use. We just use half of a u plus v times t. So S will be equal to, so now we're trying to find S now. Half of 8 plus 25 times 5. S is equal to 82.5 meters. So the distance from A to B is 82.5. So this distance to midpoint must be half of that, which is 41.25 meters. So now we have to do the journey from A to the midpoint of AB, A to midpoint of AB, set up SUVAT for that journey. So we know the distance is 41.25. We know the initial speed is 8. We want to find the final velocity with which it passes the midpoint. So that's the question mark. Acceleration is, we've worked out already, 3.4. And we don't know the time at which it passed the midpoint. So we've got SUVA. So that means we're using the formula, the v squared, that involves all 4 of those, which is v squared is equal to u squared plus 2as. Which means v squared is equal to 8 squared plus 2 times 3.4 times 41.25. If I want to find v, I'm square rooting all of this. Which means v is equal to 18.5607, which means v is equal to 18.6 meters per second. A particle is accelerated at a constant of 6 meters per second squared. After 8 seconds, its displacement is 5 meters. So part 1, what is the velocity after 8 seconds? So again, we're going to set up SUVAT. We know the displacement is 5. We do not know the initial speed. We're trying to find the final speed. We know acceleration is 6, and we know the time is 8. So we have SUAT, which means we're using the formula S is equal to, so not U, undo. We have, because we don't have it, we're trying to find V, so SVAT. So S is equal to VT minus half AT squared. So 5 is equal to V times 8 minus half times 6 times 8 squared. I end up getting 5 is equal to 8V, take away 192. So V will be equal to 192 plus 5 divided by 8, which is equal to 24.625 meters per second. 2. What was its initial speed? So if we rewrite what we do know, so still displacement is 5. We know We don't know the initial speed, which is what we're trying to find out. We know the final speed is 24.625. We know acceleration is 6 and the time is still 8. So we can use any equation in this case. So I'm just going to use S is equal to ut plus half at squared. So 5 is equal to u times 8 plus half times 6 times 8 squared, which means 5 is equal to 8u plus 192. So u would be equal to 5 minus 192 over 8, which gives us a value of negative 23.375 meters per second. Part 3. Describe the motion of the particle over these 8 seconds. So what we do know is initially the particle has speed of 23.375. Initially, the particle has a speed of 23.375 meters per second, but moving in the negative direction because it's negative. Acceleration is constant at 86 meters per second squared. During the next 8 seconds, particle, slows down until it is momentarily stationary. Because obviously we had the speed has gone from negative in initial velocity to positive final velocity, so there has to be a point where this particle is stationary. So then it speeds up to a maximum of 24.625 meters per second, traveling in the positive direction now. The displacement is 5 meters from the starting point. The cyclist is traveling at 12 meters per second. Traveling at 12 meters per second, applies her brakes and comes to rest after traveling 36 meters in a straight line. Assuming that the brakes cause the cyclist to decelerate uniformly, find the deceleration. Because it's one journey, we don't need to label the journey. So we know the displacement is 36 meters. Initial speed is 12. Because she applies her brakes and comes to rest, the final velocity is 0. Acceleration is what we're trying to find out. Time we don't have. So we've got SUVA. So that means we're going to use the formula V squared is equal to U squared plus 2AS, which means 0 squared is equal to 12 squared plus 2 times A times 36, which means acceleration, if I rearrange it, will be negative 12 squared over 2 times 36, which means acceleration will be equal to negative 2 meters per second squared. A train is moving along a straight horizontal track with constant acceleration. The train passes a signal with a velocity of 54 kilometers per hour and a second signal with a velocity of 72 kilometers per hour. The distance between the two signals is 500 meters. Find in meters per second squared the acceleration of the train. So because some of the units are in standard units meters and meters per second, we do need to convert these speed to meters per second as well. So what do we know? We know the displacement is 500 meters. So 500. Initial speed is 54 kilometers per hour, which is equal to 54,000 meters per hour to get into meters per second, I need to divide by 60 and then divide by 60 again. So I end up getting 15 meters per second. So divide by 60. So let me just times by 1,000, divide by 60 and divide by 60. Okay, similarly for 72 kilometers per hour, which is the final velocity, that is 72,000 meters per hour. And then if I divide by 60 and divide by 60, I end up getting 20 meters per second. So times by 1,000, divide by 60, divide by 60 for the second part. Acceleration is what I'm trying to find out. There is no time involved. So I've got SUVA. So again, I know V squared is equal to U squared plus 2AS, which means 20 squared is equal to 15 squared plus 2A times 500, which means if I rearrange this, I get 20 squared take away 15 squared over 2 times 500. If I put that in my calculator, I get 0.175 meters per second squared. A particle moves along a straight line with constant acceleration 3 meters per second squared. The particle moves 38 meters in 4 seconds. Find the initial velocity of the particle and find the final velocity of the particle. Again, it's one journey, so everything will stay the same. So displacement is 38. Initial speed is what we're trying to find out for part A, and also the final speed is what we're trying to find out for part B. Acceleration is 3 and the time is 4. So for part A, we've got S, U, A, and T. So that means S is equal to UT plus half AT squared is the formula that we'll use. So 38 is equal to 4U plus half times 3 times 4 squared, which is 38 is equal to 4U plus 24. So U will be equal to 38 minus 24 over 4. U is 3.5 meters per second. For part B, we've got, instead of U, I like to use what we're given. We've got V that we're trying to find. So I would use S is equal to VT minus half AT squared. So 38 is equal to 4V take away half times 3 times 4 squared, which is 38 is equal to 4V plus 24. So V would be equal to, minus 24. V will be equal to 38 plus 24 divided by 4, which means V is equal to 15.5 meters per second. A particle is moving along a straight line, O to A, with constant acceleration 2.5 meters per second. At time t equals 0, the particle passes through the origin with speed 8 meters per second and is moving in the direction of O to A. The distance O to A is 40 meters. Find A, the time taken for the particle to move from O to A. So let's see what we do know. It's one journey again, so it's fine. So displacement is 40 meters, so 40. Initial speed is 8. We don't know the final speed. We know acceleration is 2.5, and that we're trying to find the time taken. So we've got S, U, A, and T. So that means S is equal to UT plus half AT squared. So 40 is equal to 8T plus half times 2.5 times T squared, which means 40 is equal to 8T plus 1.25 T squared. If I take everything to the right hand side, I get 1.25 T squared plus 8T minus 40 equals 0. So using the quadratic formula, we get t is equal to minus 8 plus or minus 8 squared minus 4 times 1.25 times minus 40 all over 2 times 1.25. And we get t is equal to either 3.29923, blah, 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 or t is equal to minus 9.69923. Now, as t is greater than 0, because it's time we're measuring, t must be equal to 3.29923, which means t is equal to 3.30 second. That's part A. Part B, the speed of the particle at A, give your answer to 1 decimal. So that's the final speed. So if we set it up again, B, S is equal to U is equal to V is equal to A is equal to T is equal to. So we know the displacement is still 40. Initial speed is 8. The final speed is what we're trying to work out. Acceleration is 2.5. We know the time from part A, but we try not to use what we worked out, just in case there's a mistake there. So that means we've got S, U, V, and A. So V squared is equal to U squared plus 2AS. So V squared is equal to 8 squared plus 2 times 2.5 times 40, which means V is equal to square root of all this. V is equal to 16.24807 from my calculator. So V must be equal to 16.2 meters per second. Next question. A particle P is moving on the x-axis with constant deceleration at 4 meters per second squared. At time t equals 0, P passes through the origin with velocity 14 meters per second in the positive direction. The point A lies on the axis and OA is equal to 22.5. Find the distance between the times when P passes through A. So if we set up SUVAT again, so we know the displacement is 22.5 meters. Initial speed is 14. We don't know the final speed. We know acceleration is 4 meters per second squared. We're trying to find the time. So we've got S, U, A, and T, which means S is equal to UT plus half AT squared. 22.5 is equal to 14 times T plus half times 4 times T squared. I just realized the acceleration, constant deceleration, it says, so it's -4. Oops, -4. So read it carefully. Constant deceleration at 4 meters per second squared. Okay, so that means I get 22.5 is equal to 14t minus 2t squared. If I take everything to the left-hand side, I end up getting 2t squared minus 14t plus 22.5 is equal to 0. Using the quadratic formula, I end up getting minus b, so it's 14 plus or minus 14 squared minus 4 times 2 times 22.5 all over 4 times, so 2 times 2. I get t is equal to 4.5 or t is equal to 2.5, which means time difference between time is equal to 4.5 seconds take away 2.5 seconds, which is equal to 2 seconds. Now the reason behind this is it's decelerating. So it's slowing down. So it's going to go through point A as it's slowing down. But eventually after it passes through point A, there'll come a point where it stops and then it comes back. Travels in the opposite direction, so it's going to go through A again. So that's why it's going to go through A twice, because it's going to slow down until it moves in the negative direction. Okay, part B. the total distance traveled by P during the interval between these times. So what we do know is we have O to A, which is 22.5 meters. So what we need to do is we need to find the point. So particle P will go like this and then come back. So we need to find how much distance it travels to get to the point where velocity is equal to 0. So at this point, when it turns around, velocity is equal to 0. So we need to do from O to V equals 0, okay, when the velocity is equal to 0. So if I set up SUVAT, we're trying to find this displacement because we don't know the journey. So question mark, initial speed we do know is 14. And now in this journey, the final speed is 0. Acceleration is -4, and we don't know the time it takes. So we've got S, U, V, and A, which means V squared is equal to U squared plus 2AS. 0 squared is equal to 14 squared plus 2 times minus 4 times S, which means S will be equal to minus 14 squared over 2 times minus 4. S is equal to 24.5 meters. So that means if this thing is 22.5, this must be 2. This must be 2 meters, which means if it's traveling, the total distance traveled by P during the interval between these points is just going to be the 2 meters there and then the 2 meters back. So it'll be 2 meters plus 2 meters, which is equal to 4 meters. So distance traveled by P during interval is equal to 4 meters in total. Next question, a car is traveling along a straight horizontal road with a constant acceleration. The car passes over 3 consecutive points A, B, C, with A to B equal to 100. So let's just draw this out. A, B, C. A to B is 100 meters. B to C is 300 meters. The speed of the car at B is equal to 14 meters per second. The speed at C is equal to 20 meters per second. Find the acceleration of the car. Now, because we have the speed at B and C, we look at the journey. For A, we're looking at the journey from B to C only when we're setting up SUVAT. Okay, so it's a journey from B to C. We know the displacement is 300. The initial speed is 14. The final speed is 20. Acceleration is what we're trying to find. We don't know the time. So we got S, U, V, and A. So V squared is equal to U squared plus 2AS, which means 20 squared is equal to 14 squared plus 2A times 300, which means A will be equal to 20 squared, take away 14 squared, over 2 times 300, which means acceleration will be equal to 0.34 meters per second squared. The time taken for the car to travel from A to C. So now we know that acceleration is 0.34 meters per second squared. So when we from A to C means we're going to consider the whole journey. For this part, we're going to consider the whole journey from A to C. So if we're setting up SUVAT for the whole journey, the displacement is 400 meters. The initial speed, we don't know. We weren't given it. The final speed is 20. We know the acceleration is 0.34 from the part A, and time is what we're trying to find. So what we have in front of us is SVAT. So the formula we use is S is equal to VT minus half AT squared. So 400 is equal to 20 times T minus half times 0.34 times T squared, which means 400 is equal to 20t minus 0.17t squared. Take everything to the left-hand side. So I get 0.17t squared. Take away 20t plus 400 is equal to 0. Using the quadratic formula, minus b is 20 plus or minus 20 squared minus 4 times 0.17 times 400 all over 2 times a, which is 2 times 0.17, which means we get the value t is equal to 92.09914 and t is equal to 25.5479. We now take the first value for which the first positive value, which means t is equal to 25.5479, which means t is equal to 25.5 seconds. Okay. In an orienteering competition, a competitor moves in a straight line past 3 checkpoints, P, Q, and R. Where P to Q is 2.4 kilometers. And Q to R is 11.5. The competitor is modeled as a particle moving with constant acceleration. It takes 1 hour from P to Q and 1.5 hour from Q to R. We don't know the speed. We don't know the acceleration. Okay, so there's a lot of unknowns. So we know, let's call this velocity at P, velocity at Q, and velocity at R. So if we look at the journey, it looks like, and we have this acceleration, which we don't know what the value is. So it looks like, because we have 2 separate journeys, we should be able to solve it simultaneously with 2 unknowns. So what I would do is first look at the journey from P to Q. So because VQ is involved in both, let's try to set up a simultaneous equation with VQ and obviously acceleration, because that's what we're trying to find. So if you set up SUVAT now, so it's in kilometers an hour and kilometers per hour, so it should be fine to use not to change units. So we know it's 2.4 kilometers, the displacement from A to, so P to Q. The initial speed we don't care about, because we want to involve the final speed, which is V, the speed at Q. Acceleration is A, and the time is 1 hour. So if you look at what we have, we've got S, V, A, and T. So that means S is equal to VT minus half AT squared. So that means 2.4 is equal to VQ times 1 minus half times A times 1 squared. So that means VQ is equal to 2.4 plus half A. So let's call that equation 1. Now let's do the same thing with the journey from Q to R, because that also involves V of Q. So S is equal to U is equal to V is equal to A is equal to T is equal to. Now we know the displacement is 11.5 here. Initial speed is now V of Q. We don't care about the final speed. Acceleration is A and the time is 1.5. So we've got S, U, A, and T. So S is equal to UT plus half AT squared. So 11.5 is equal to VQ times 1.5 plus half A times 1.5 squared, which means 11.5 is equal to 1.5 VQ plus 1.125 A. And this is equation 2. So what we need to do now is substitute 1 into 2. So what we end up with is 11.5 is equal to 1.5 times 2.4 plus half A plus 1.125. If we expand the bracket, we get 11.5 is equal to 3.6 plus 0.75a plus 1.125a. Put the a there. Which means a will be, when you add it together, you get 11.5 take away 3.6 is 7.9, and 0.75a plus 1.125a is equal to 1.875. So a is equal to 7.9 over 1.875, which means a is equal to 4.213 recurring, which is equal to 4.21 meters per second squared. No, not meters per second. Kilometers per hour squared. Kilometers per hour squared. Part B. Her speed at the instant she passes P. So we look at the journey P to Q only. So S is equal to U is equal to V, A, and T. So if we're looking from P to Q, the displacement is 2.4. We're trying to find the speed at P, so that is what we're trying to find. We don't know the speed at Q. Acceleration is 4.213 recurring, use the non-rounded version. And the time is 1, because we're getting this 1 hour. So we have S, U, A, and T. So S is equal to UT plus half AT squared. So 2.4 is equal to U times 1, which is U, plus half times 4.213 recurring times T squared, which is 1 squared. So U will be equal to 2.4 minus half times 4.213 recurring, which is equal to 0.293 recurring kilometers per hour, which is equal 0.293 recurring, which is equal to 0.29, which is equal to 0.293 kilometers per hour.